Hi, everyone. I'm JCarzoli, and I'm from the Neurophysiology of Movement Lab at CU Boulder. As you can see from the title, I'll be discussing our lab's recent data collection assessing the influence of sensory-focused electrical stimulation on walking endurance in healthy middle-aged adults. And we use transcutaneous electrical nerve stimulation, or TENS, which is applied superficially over a muscle between two electrodes with low stimulus intensities. Importantly, a user can adjust many of these stimulation parameters for various goals. And at low intensities, the user will often feel a tingling sensation as a spectrum of sensory neurons are activated. And as the intensity increases, eventually muscle contractions can be evoked. Now, our lab has been exploring the use of stimulus intensities set to motor threshold, or the point at which slight muscle twitches are first noticed. And a study using that approach was published last year by Almaclass et al. And assessed how TENS applied over the quadriceps and tibialis anterior muscles affected walking endurance in individuals with multiple sclerosis. And this study used healthy age and sex-matched control subjects and found, surprisingly, that the control subjects also increased 6-minute walk distance with added TENS compared to a sham condition. And originally, we weren't sure when during the test there were the greatest benefits from the supplementary sensory feedback provided by TENS. But further analysis of this study's data answered that question. And just to orient us to this figure, the y-axis displays the difference in distances walked between the TENS and sham conditions for each 2-minute increment of a 6-minute walk test displayed on the x-axis. So a y-axis value greater than 0 means the group on average walked further with TENS than without for that 2-minute increment, and a y-axis value less than 0 means the group walked further during the sham condition compared to the TENS condition in that 2-minute increment. And for the individuals with multiple sclerosis, we can see they had a consistent increase of about 5 to 8 further meters walked for each 2-minute increment of the test with added TENS. For the control subjects, however, they had increased distance walked up to 4 minutes and then decreased distance walked in the final 2 minutes of the test with added TENS. So what does this mean? Well, TENS provided the control subjects the beneficial effect for the first 4 minutes and then a detrimental effect for the final 2 minutes of the test. And one reason we believe this occurred is due to nerve accommodation, which is a gradual rise in voltage threshold resulting from continuous long-lasting stimulation, which was the form of TENS used by Almaclass and colleagues. And when voltage threshold rises, a nerve is less susceptible to being activated. Now, another important factor is that sensory and motor neurons tend to fire bursts of action potentials at the onset of activation. So perhaps bursts of stimulation, as opposed to continuous stimulation, could provide beneficial sensory feedback, avoid nerve accommodation, and mimic physiological firing patterns. Essentially, maybe bursting patterns of TENS can provide the benefits of continuous TENS without eventually compromising motor performance. So based on these findings, we tested the performance of healthy middle-aged adults with TENS applied over their tibialis anterior and quadriceps muscles in 4 trials of a 6-minute walk test with different stimulation patterns that I'll describe in just a bit. Importantly, all 3 TENS conditions had the same stimulus intensity applied, just the pulse patterns changed. We compared distances walked between conditions with the repeated measures ANOVA and believed that including burst TENS trials may indicate if nerve accommodation occurs from continuous TENS. And here are the specific pulse patterns for each TENS condition. The continuous TENS had a pulse rate of 50 hertz and pulse width of 200 microseconds. The fast burst TENS produced 5 bursts of 7 pulses each second, and the slow burst TENS produced 1 burst of 7 pulses every 2 seconds. So for our study design, participants came in for 2 visits, the first of which was fixed so that they performed a baseline 6-minute walk wearing the TENS pads, but the devices were turned off. And this was followed by 30 minutes of rest and then a continuous TENS 6-minute walk test with the stimulus intensity set to motor threshold. 3 to 7 days later, and within a 1-hour start time of the first visit start time, participants performed 2 6-minute walk tests with either fast or slow burst TENS applied, which were counterbalanced between participants and separated by 30 minutes of rest. So we were unable to access the indoor track at CU's rec center, so we decided to use a long hallway on CU Boulder's campus to lay out a 60-meter walkway that the participants walked down and back on for testing. So here's an example of one of our younger participants at the starting line of the test, and she was wearing the TENS pads over her quadriceps and tibialis anterior muscles with the TENS devices hooked onto the back of her waistband. And we told all participants to walk at what felt like a brisk walk pace for each trial. So jumping to the results, repeated measures in NOVA and post-hoc analysis showed that all 3 TENS conditions resulted in greater distances walked than baseline, and that both fast and slow burst TENS conditions resulted in even greater distances walked than continuous TENS, with no difference between fast and slow burst conditions. And here are the data graphed for each individual participant, and clearly not all participants conformed to the group trend, as several walked furthest during their baseline test. As an example, participants ranging from our fastest to our second slowest walkers, determined by baseline walking distance, walked further during their baseline test than any TENS conditions. Additional analysis of the distances walked just during minutes 5 and 6 revealed that all 3 TENS conditions resulted in greater distances than baseline, with no significant difference between TENS conditions. And again, interestingly, not all participants conformed to this trend, as several walked furthest in minutes 5 and 6 during their baseline tests, and these appear to be the same individuals who walked a greater total 6-minute walk distance during the same trial. So to conclude, fast burst and slow burst TENS conditions resulted in greater 6-minute walk distances than no TENS or continuous TENS trials. Fast and slow burst TENS were similarly beneficial, and not all participants fit this general trend. And we hope future research can provide insight on why individuals respond differently to supplemental TENS for motor performance. And finally, unlike Amaclass and colleagues, there's no decrease in distance walked in minutes 5 and 6 for continuous TENS compared to baseline, which is potentially affected by the deceleration and acceleration at turns, and unfortunately does not allow us to make any conclusions about nerve accommodation just yet. So with that, I thank you all for your time, and now I'll open it up for questions.